Hello class. So there has been a request uh, about a few questions from the previous exam. So we're going to try to have the solutions together. Okay, let's look at the first one. Here, what I was asking was if you can rationalize the denominator. All right. Then here, one thing which we can do is notice that it's not a simple square root. Then we would have used simple conjugate. But here we have the cube root. The way which we're going to do is here we want to cube each one of them. Then in that case, we get to rationalize the denominator. So what we end up getting is I'm going to use this factoring, which is x minus y times x squared plus xy plus y squared. Notice what I have here is this one. If I have this expression multiplying through that, then I get to cube each of the terms. So what I'll do is I'll multiply by 2 squared, which is 4, plus product of these two, which is 2, cube root of 3, and plus square of that, which is cube root of 9. And I'm going to do exactly the same thing in top and bottom right over here. Then what we end up getting is the denominator when you multiply them, or you can just use the factoring relationship here. Then we get to cube the first one, which is 2 to the third power, minus cubing the second one, which is simply 3. And the top is the same thing. Because when you multiply by 1, you get exactly the same expression. And therefore, our answer is, same expression right over here. For the numerator, divide by 8 minus 3, which is equal to 5. So that becomes my final answer. All right, number 3 was the other question here. How are we going to do this? Let's try to identify what each I to the certain power might have been. So I to the 2012, since 2012 is the 0 mod 4, or you will get 0 when you divide by 4, this will be equal to 1. That makes 2013 as I, and 2015 becomes negative I. Now, when I say evaluate, the word evaluate implies a simplification. So in fact, this becomes simply 2 times 1, and then minus I over I. Now, if you to rationalize the denominator, when you multiply top and bottom by I, we get 2I minus I squared over denominator becomes I squared. Then this becomes 2I plus 1 divided by negative 1. So our final answer is negative 2I minus 1 becomes our final answer. All right, number 4. We want to figure out the value of x. But notice that the square root of 7 times square root of 7 times, all these patterns continues. So in fact, this can be rewritten as square root of 7x equals x. When you square both sides, then we get 7x equals x squared. And then bring things over, 0 equals x squared minus 7x, which is equal to x times x minus 7. Then you will realize that x will be equal to either 0 or 7, but it cannot be 0 because we realize the square root of 7 already is greater than 0. And keep on multiplying by something that's greater than 0 will never be equal to 0. So 0 has to be rejected, and 7 becomes our final answer. Now, number 5. Here, which many of you guys had a difficulty. Now, what I want you to do is I want you to express this one in the simplest form. And one thing that we can do is we can cancel out whatever is common on the factor here and the factor here. So x cubes cancels out right away. and we realize that y's can combine together, and 2 and 6 cancels, that becomes 3, and z can go up. So in other words, we end up getting z to the 4th power is on top, and then on the denominator we'll end up having 3 and y to the 12th power first, because when you bring this y to the denominator. Now we're going to rewrite this one. We get 3 x to the negative 2, y to the 5th, and z to the negative 1, minus, notice this is 12 to the negative 1, and x to the 4th and z to the 6th power. So let us try to do that together. Let's see what we end up getting. Rest of them is about the same, so we have 3 x negative 2, y to the 5th, and z to the 3rd. When you multiply z to the 4th to the first term, and then if I have to do the second term here, we get negative 12 to the negative 1 power, x to the 4th, z to the 10th, all over 3 y to the 12th power. So here, if I want to, I have two ways for me to go about doing it. Since, I mean, the concept of simplification, I can make this one into two different fractions. If I do that, in fact, then it looks much nicer, actually. Then what we end up getting is 3x to the negative 2, y to the 5th power, z to the 3rd power, all over 3 y to the 12th power, minus 12 to the negative 1 power, and x to the 4th, z to the 10th, all over 3 y to the 12th. Then here what we end up getting is, along this route, you get to see that 3's can cancel out, and here z to the 3rd is on top, but on the bottom we have x squared and y to the 17th power. Now minus, here we get 12 to the negative 1 power brings 12 to the bottom, we end up getting 36, and y to the 12th power, and x to the 4th, and z to the 10th. So that's one way for us to write them. Or if you want to just keep this one as they are, so that's one answer. Or another answer would have been all the negative exponent we have to multiply by the positive one to get rid of them. So what I'm going to do is I'm going to multiply top by x squared, and then 12 to the I mean simply 12. Then I'll be getting so what I'm going to do is I'm going to make that into 1, bring that in, and I'm going to multiply top by x squared so that I can cancel this one out, and also I can multiply this one by 12 so that I can cancel this one out. But I got to do exactly the same thing on the other side also. Here we get x squared times 12. Then let's see what we end up getting. X squared cancels out. Here we end up having 3 y to the 5th and z to the 3rd. But we have to have 12 multiplying, so in fact we get 36. For the second one, 12 cancels out, but minus x to the 6th, because 4 and then 2, and z to the 10th. All over becomes 36, and this one is not there. And then x squared and y to the 12th power. And there's nothing that's common, so this can be another answer that is most simplified. All right, so that's about it. I'll see you guys later. Bye-bye.